Hello, this is Introduction to ISAT Revision 5 Classroom Satellite Kit. This kit can be used in conjunction with satellite design, a course to teach space systems engineering. Now what I'm going to do is I'm going to show you the various subsystems, various components, various various boards of this classroom satellite kit and give you an overview of what this can do. Let me start with the constituents of this ISAT Revision 5 Classroom Satellite Kit. This is the base of ISAT Classroom Satellite Kit. What you see here, these are the magnet torques, and these are just balances to balance out the weight of these magnet torquers. The magnet torquers are typically used for stabilizing the satellite. What you see at the bottom is this is called the separation switch, and it emulates the launch of a typical satellite out of a launch vehicle or a pod or a deployer, a satellite deployer. Now what you're going to see here, this is the common bus. It's called the ISAT bus. All these boards, I'll show you one by one, will be able to connect to each other through this common ISAT satellite bus. And these are the guides for these boards. This is the electrical power system board, or the power distribution board as it is called in the manual. This is used for connecting to the solar cells, and what you see at the bottom, this is the battery, onboard battery for the ISAT classroom satellite kit. Now if you see these, you can test the various regulated voltages, supplies, or not supplies, but the regulated voltages here on these pins. Now the way this board physically mounts to the satellite is through these guides. What you're going to see is I'm going to slide these standoffs. These are standoffs. There are 4 standoffs here, which are going to guide through these guides. That's how they physically connect to the structure of the satellite. What you're going to see is, you see this one, this is the ISAT bus, electrical and communication bus. This is going to electrically connect to these magnet torquers, a separation switch, and a bottom sum sensor. Okay, just get it to the point and then push it. Alright, that's secured now. On top of this, what you're going to see is we have the ISAT command and data handling system. This is the onboard computer. What you're going to see here is this, in a typical satellite, manages everything. This is the heart of the satellite. Everything gets controlled, everything gets decided by this onboard computer. Now the way this onboard computer is powered by the electrical power system, and again this connects to the ISAT bus. Now this is how it connects. And then what you're going to see is this is the satellite radio. Now the satellite radio is complemented by this is the radio which connects to a computer, and you can remotely control the satellite. And this emulates the ground system to satellite communication. This is just an XP connector or an XP radio, and what whatever the ground station sends, whatever this sends is received by this satellite radio, and then it goes to the command and data handling system or the onboard computer where the decision happens. And then what you're going to see is this is the attitude determination and control system. What you're seeing here is this is the reaction wheel or the momentum wheel. You have the attitude computer on this one, the magnet torquers and the sun sensor are controlled, are managed by this ADCS computer. And this ADCS computer goes on top of the onboard communication system. Now what you're going to see is this satellite also has a solar panel which you can demonstrate. This would be my typical sun, and I can show through experiments that how solar cells can be used to charge the batteries. Now what you're seeing here is there are 6 solar cells, and solar cell or a solar panel has a provision of connecting these solar cells as different series and parallel combinations. So you're going to see here it is 3 series 2 panels and 2 series 3 parallel. Again, it's 3 series 2 parallel, 2 series 3 parallel. Those are the 2 options available. Now what you're going to see is when you connect them in these configurations, the current and the voltage produced by the solar cells, the combined voltage and the current flowing through out of these solar cells changes. And again, this is something we're going to discuss when we discuss each of these subsystems. You will also see a temperature panel, a thermal panel. Now this is very useful in demonstrating how various surfaces, now if you see here there's a white surface and then there's a black surface. Now what you can do is you can demonstrate how satellites can regulate temperature in space. It can get really hot and it can get really cold in space, and we want to show the students or the participants how temperature can be controlled by having various types of thermal surfaces. What you're seeing here is the top panel, and this top panel has sun sensors on it. You can see there are 5 sun sensors here. So this is called the top sun sensor, and then you can see here there are, if I show you here, there are 1, 2, 3, and 4 sun sensors on the side. And there is top sun sensor, and there is 1 bottom sun sensor here. By combining the measurement from these 6 sun sensors, you can figure out where the sun is, which can be used as one of the vectors for determining the relative attitude of the satellite. So this is about ISAT classroom satellite. Okay. To conclude, what you're seeing is this also comes with 2 of these panels which complete the structure, and there are various connectors available. There is a breakout board for testing and for carrying out experiments, and there is there are all sorts of different accessories to help use the satellite kit for experimentation purpose, for training purpose. Thank you for your attention.